This is Dr. Richard, and this is my DARPA laboratory. I developed this Psychothotonix methodology when I was working at Caltech, and it became indirectly part of a movie that got an Oscar for special effects in movies. This is the way we started the PT camera. PT camera is called the Psychothotonix camera because it can take images of the internal mind, or it can take images of anything external. So from this point forward, just think of the Psychothotonix camera as the PT camera that can allow us to take any kind of picture that we want on any path. Like a regular camera can take only images of the external material world, whereas a Thotonix camera can take images inside somebody's brain, it could take images inside of a dream, inside of a hallucination. It could take pictures of somebody who's in a hologram in another universe.
Are you in, Doctor?
Yes,
Good morning.
oh, hello there. Good morning. Nurse Nespa.
Yes, Doctor.
I think the patient is ready.
Holographic display.
She's ready
So the
to
hologram. Our holograms are created, and by the way, this is an image of another universe. It could be Atlantis, I'm not really sure. We haven't figured that part out yet. This is the PT camera in action. PT cameras in action. Notice these images are coming from infinite number of universes. We don't know if that's somebody's brain exactly. Let's have to filter this data out more. Think of a hologram, for example. If you go to Disneyland and you look at Snoopy, who's floating in free space, that hologram of Snoopy is actually what I call a Thotonix image, because it's an image created from matter, and so it's a matter image. So that's what a Thotonix image is. Originally it was developed in quantum mechanics, and in quantum mechanics the way it was shown and proven to be is an electron could be here and then it traveled to here. But oddly enough, when the electron was here, it could potentially travel infinite number of paths, and we could say that it had a probability of being in an infinite number of places at one point in time, and then eventually it came out to be here. So if I had a camera, I could see the electron here, and then I could see the electron here. But the problem with quantum mechanics is that you can't see all the other states of where the electron is. So therefore I figured out these are what we call the Thotonix image states. These are Photonics because they're not visible by a camera. So I developed the Psychothotonix camera, and the Psychothotonix camera is able to see matter objects and then anything in between. For example, in Tetrastatum, which uses all of my Psychothotonix methodology, we can see that in this case a human, Dr. Smith, went to various places. He went to the Luxor in Vegas, he went to Adwat, which is an insane asylum, then he transferred to the Universal Depot, he also went to Egypt, he went to Atlantis, and then eventually, in the end, he came back to DARPA with me, and then we were both on a court case where we had to be on trial for tampering with reality. This is the core for quantum teleportation using the Psychothotonix camera to capture all of these images. So in this case, taking a simple example, here's an electron, which is a matter object. So the PT camera can take a picture of the matter object, and we could also take a picture of a non-matter object. So in this case, this is time flowing in this direction. The electron moved in time, frame by frame, and when it moved from here to here, all of a sudden it disappeared. Where did it go? Doesn't make any sense. And then it reappeared again. Well, half of the problem with Schrodinger's equation is that it only answers half the question of what is reality. Schrodinger's equation says the electron was here and has no probability of being here, but has a 100% probability of being here. So where did it go? Well, one of the things we discovered in the Psychothotonix DARPA laboratory is that a thing called cloaking can happen. So when the electron went from here to here, we found out that it was cloaked because the PT camera can look behind a cloak. A cloak is a space-time cloud. Think of it as a space-time cloud. So the cloud covers over where the electron was, and lo and behold, we find it here. And so it's cloaked. So that was a new discovery, and that's what helps us understand how to transport anything, because all humans are made of electrons, particles. They're all built up together, right? And so a body is just a bunch of these electrons. So if we were imaging a person, it would be the same kind of effect. So again, as you can see, then it disappears again. So the duality here is it was here, then it wasn't here, it was here, it wasn't here. This is along one timeline. The Psychothotonix camera, in this case, saw behind the cloak, and then this was disappeared, and then because it showed the electron being here, and then disappearing and being here. So there's a duality involved for everything.
Like looking at two different layers at the same time, Doctor.
Exactly. Two different layers at the same time. So this is one universe A, because there could be other universes, universe B, universe C, universe infinity. So there's infinite number of universes. So the wave equation, what it does is it solves the other half of Schrodinger's equation. So let's say this is the real part of Schrodinger's equation. It says there's a zero probability of the electron being here, but it doesn't make any sense. So I discovered that has to be incorrect. So I rederived Schrodinger's equation, and I came up with the imaginary part, and I created another wave called a Psychothotonix wave. And the wave attaches to each one of the images. So the wave and the image are equivalent to each other, as you can see here. It goes from 0 to 1 to 0. So it oscillates back and forth. But in reality, it takes another frame. So it's never 0, it's actually an image. So by expanding the Schrodinger equation, we can now have a continuous image of the way the particle moves. Now another example is the particle could be an electron, and the electron, when it moved here, it actually did disappear, not behind a cloak, but it recreated itself as a dual opposite particle, which is called an anti-electron. And it could be any particle. It could be a photon that creates into an anti-photon. It could be a K-meson that turns into an anti-K-meson. It could be any particle. It could be a whole atom turning into another atom, or a group of atoms turning into an anti-human, a dual opposite human. So the PT...
But everything will be equivalent, Doctor?
Everything would be equivalent. So we just build up this wave duality into a whole process we can transform the human being and have him move in time in different frames. We can also extend this diagram to another universe, universe B. Notice here the electron was transformed into an electron, but in this case the electron has positive energy, whereas here it had negative energy, so it's a dual opposite. So duality is always maintained in everything that happens. And then the same logic applies here. The electron with positive energy disappeared, and it showed up as an electron, anti-electron. So the process continues. Any way you look at this, you're going to get duality. And it's, again, explained in much more detail in the back of the book. I want to talk a little bit about experiential realities, because experiential realities involve this as well. Experiential realities can include dreams, electrons, anything. Like I said, this could be a dream. So if this was a dream, a solid dream would be a photonics dream, and this would be another photonics dream. So a dream can actually be what's called an image matter-free image, just like the Snoopy diagram. Snoopy was a hologram in space, but it's an image of matter, so that's still a photonics image. And it could be in your brain, so that's a photonics image.
existing in multiple states at once, Doctor.
You'll be in multiple states at once. And we learned this from our dolphin experiment, actually. We had the dolphins back there in the room. I'm going to take you back there and show them. No, we'll do that later. And we learned that the dolphins take instantaneous and simultaneous photonics, which is the internal in their brain, or external photonic images in the exterior world, anywhere in space-time experiential reality. Each of the laser crystals have different wavelengths that connect all over the universe through photonic axons, which are space-time holes in the universes, in parallel universes that connect everywhere. Now the pattern that you push on the laser crystals, they can take us anywhere that we want. Those alter anytime travel. Anytime travel. As you can see, those start to show up as electronics on the Psychothotonix computer. This is the computer that takes me all over the universe, and they show up as images anywhere. So right now we have 6 control devices, but I can bring out of the laboratory an infinite number of these types of control crystals. These crystals cover the entire spectrum that's even beyond the visible, beyond terahertz, beyond X-rays. It's in the Psychothotonix spectrum, which goes from 0 to infinity. So therefore, we just alter all of these and we go anywhere in the universe. Because the Psychothotonix camera does work on a laser, which is called a slow light laser. And it's very involved, but these are basically slow light laser photons that slow the shutter speed down in a camera so that we can see things instantaneously. Without things being instantaneous, in other words, photons slowed down to 0, or as we call them, virtual photons or photons, we wouldn't be able to travel. It'd be impossible because we'd be locked into what's called the Einstein light cone. We can't travel outside of the light cone. But with this technology, that allows us to increase the shutter speed of the camera, the PT camera, so we can go outside of anything. And this is what the dolphins do. Again, I discovered this with the dolphins because when we did the experiments with the dolphins, we found that they were able to transfer their images simultaneously, which we saw here, into seeing other dolphins in different parts of the ocean, so they could see the photonic images or the photonic images, matter or non-matter, but then they could also jump out and go into other parallel universes, and we saw this happening with them. So they have the biological basics for the PT camera. So we analyzed that, and we did it nicely. We didn't take their brains out. And now she's looking at, this is one of our contraptions. It's actually a very dangerous thing, so don't get too close to it. Sometimes these things jump out at you, and it's coming, and especially with her. So, you see when I go over here, they don't jump out. Why? Because I'm ugly. Doesn't matter. But she goes over here, and they jump right out. They're gonna jump out. So I'm glad that we kind of reviewed that. But oh, look at this. We've got some interesting stuff coming in here. All of these are the imaginary solutions of the Psychothotonix equation. They keep changing. This one keeps coming back, so I think it's possibly going to turn into Time Smith at the Luxor in Las Vegas. That's my calculation. I'm working on it. I'm working on it. Now, is it going to be real? Is it a real image? Is it a matter image in Atlantis? Or is it going to turn into just a photonic image in the universe? Now, clearly the nurse, as I see it, is both a photonics and a photonics image. Photonics is the matter part of her, and I can't touch her.
I'm fairly sure I'm here and that I'm also up there, huh, Doctor?
And she's up, yes, she's up there, and I have many thoughts, and they keep expanding to infinity. I'm sorry. Now I'd like to go into, Dr. Smith, a little bit more involved derivation of how I manipulated Schrodinger's equation to be able to develop all of this around here, including all the different time travel things that we can see going on in my DARPA lab. I started out with Schrodinger's equation, which we all know. This is IH bar times the partial derivative of psi in terms of time relative to time. And in quantum mechanics, this is a standard equation. We call this the Hamiltonian, which is the operator. It operates on the wave function psi. Now, in quantum mechanics, the wave function is always interpreted primarily as the real part of the solution, and it, as you know, is the probability amplitude of something happening. Probability amplitude of the electron, for example. Probability amplitude of electron could be 100%, 0, or 100%, as I showed you in the previous diagram. It could be 100% that it showed up at this point in time. Here's time. So the electron showed up, and if we had a camera, we could see it. But in Schrodinger's days, they didn't have cameras. And even now, the cameras can't capture the exact image of the electron being here. So this amplitude has to do with the probability amplitude of the electron being here. In this case, it's 1. So the electron would be here, if we could see it. Now the PT camera can see it, and that's part of how I evolved this. Here, the electron amplitude, as you can see, the curve goes to 0, so there's no electron there. And then over here, it goes back to 1, so the electron is here. So if you take the logic...
percentage scale then, Doctor?
What's that?
So it's a percentage scale then, Doctor. You're predicting the likelihood of where it will appear?
Yes, it's the likelihood of where it will appear. And so therefore it can be here and here, but then what happened in between? It's a very confusing thing. And so no one has ever been able to interpret that. And it has to do with the fact that if we had another wave on this, where this was 1, if it was 1 here, then we would know that the electron was actually there. So we had a shutter speed that was fast enough, we could see it continuously there. And I pointed out those two cases, standard cases. One is it disappeared behind a cloud, but we can remove the cloud so we can still see it there. Or it disappeared and created another anti-electron. So we go electron, anti-electron, electron, so forth and so on. So it wipes out the basic function of quantum mechanics, and therefore allows us to take continuous images. Now the details of developing a camera that has this kind of shutter speed was very, very complicated, but this is the basic mathematics behind it. So what I did is I changed the wave function, in this case, which is a probability amplitude wave, which has never made any sense to anybody. And through hundreds of years of analysis, no one's ever been able to figure it out and interpret it. Most greatest minds in the world. Einstein said it's nonsense. Okay, so the next thing I did is I expanded quantum mechanics, and I showed that all quantum mechanics events can be placed on a Photonics sphere. A Photonic sphere, again, is just the matter images. So let's just draw a sphere. So here's all the matter images. And I want to show you a simple example. Let's suppose that I'm taking the matter images of the state of polarization of a photon, or the state of polarization of an electron, or any particle, or the state of any quantum mechanical event, but I want to see it as an image. I showed mathematically that any one of those will fit on a sphere. I'm drawing as a circle, but it's actually a sphere, so there's an infinite number of images that can exist on the sphere. For example, those of you who know the old quantum mechanics, we could call this the X polarization state of a photon. We could call this the Y polarization state of a photon. We could call this the right circular polarization state of a photon or a particle. We call this, so that's a phasor that goes there. We could call this minus the right circular polarization of a photon, which would just mean that instead of the photon coming in through the polarizer this way, the photon came in through the polarizer this way. So I could have an image with a PT camera. I can take an image of each one of these. These form an orthonormal basis. Okay, so we can also have a left we can have left circularly polarized photon, and we can have minus a left polarized photon. So this is left circularly polarized, right circularly polarized, and so forth and so on. And all these in between would be infinite other states of polarization. So you can see we have an infinite number of these polarization states. Okay? Typically we do it this way. We call this X, we call this minus X, and we call this Y, and we call this minus IY. And we get the imaginary component in here because we need the imaginary component to turn this into waves. This is basic mathematics. Then what I did is I took this and expanded it even further, and I showed that any image of anything in the matter universe, whether it's a quantum mechanical, microscopic, nanoscopic particle, or whether it's an image of the nurse or an image of anything in this lab, they all also fit on a sphere. So for example, let's take a military example. Let's say this is a tank, and we take an image of a tank. Yeah, we see this as a tank as not a threat. So we see the tank, it's not a threat. There has to be a dual opposite image that the tank is a threat. Over here, these are off other images that are also dual, but I won't go into that right now. So when we make a, this would be the photonics image, but it's also a photonics image. That's why I call it a psychothotonix image, because after you see this, let's say this was 100% a tank that was an enemy tank, there could be any number of people that would interpret it in an infinite number of ways. Infinite number of ways. So I call this, it has an infinite number of conditions of interpretation. So this is an experiential psychothotonix oriented. Let's simplify everything. So now let's do another case, which I like a lot because it shows a very interesting thing about psychothotonix and democracy. We talk about this in the book. What is a democratic process, truly? Well, when we use the psychophotonic images, we can come up with an interesting conclusion about it. Let's suppose this is Simpson, who's in a court case, and everybody in the universe has an internet, and they all want to make a decision about his guilt or his innocence. Well, each one of those would be displayed on their screen, and they could pick different points. For example, they could say he was 100% guilty as charged. Another person could say, well, no, he was 100% guilty, but it was society's fault, so it was a dual opposite. Over here, we could say he's 100% innocent and he should have no punishment. Here we could say he's 100% innocent, but he may have to pay back the court for the court costs. So duality is always wrapped up in every image. So if you notice that if you took all the people in the world and everybody had a screen on the computer, it would be a psychothotonix computer screen, they would add all these points in here relative to the guilt of Simpson, who was at the center of the circle. So anyway, all these points would become populated. So once they're infinitely populated, what do we come up with? Oh, we come up with
Possibilities.
infinite possibilities. Infinite possibilities. But if there's infinite possibilities and we solve the psychothotonix equations of motion, what we can see is that the final answer is what? 0, we can't decide. So we have an infinite number of people trying them. Then Simpson's free, and he's free already. He just got out a few years ago. So at the end of the day, oddly enough, how can we even try democracy? This is the democratic method. If it's true democracy, then everybody is allowed to make a decision, and no matter who you find, you're always going to find a dual opposite. Now these can coalesce into regions, like you might have a lot of decisions in this region and a lot in this region, and that would throw off the overall thing. So, but I gave you the answer of where it's 0. He has no guilt, no matter who it is. Butcher, Dr. Richard, I mean not Dr. Richard, not Dr. Richard.
I hope
having
not yet, Doctor.
with the jacuzzi party later, right? So here's Beauties. We've got Nurse Nesta. We're going to say she's definitely a piece of artwork. Definitely a piece of artwork. And it's very nice to have her helping out in this laboratory. It's a very humbling job that I have.
Thank you, Doctor.
You're welcome. And so, here's how the Psychothotonix sphere can get destroyed. There's going to be all these points up here that, yes, she's a very beautiful woman, with a very beautiful figure. So in the matter universe, all the points are up here. And there's no one out there. I mean, there might be some bizarre maniac that would pick, no, she's not beautiful, or she's neutral, or whatever. But the point is, the Psychothotonix sphere allows us to put any kind of image on here. These are called experiential images because they involve my thoughts about something, or anybody's thoughts about something, their emotions, their behavioral state, were they accept it, were they reject it, were they want to run from it. So there's an infinite number of conditions, what I call C1 through C infinity. It can be an infinite number of conditions for each image. So an image is identity. And the whole point is, right now we need to, in this universe or any other universes, as the images come in, we need to place them onto a generalized artificial intelligence program that can model all of reality of anything happening. And that doesn't exist today. Now with the Psychothotonix camera and computer, we can actually create all of this mathematics. Thank you. In physics, before the PT camera, all the laws were very well focused on the conservation of matter. So matter can change from one form to another. A particle can turn from one form into another particle. But no matter how complicated all the equations are, the matter comes back and all the matter is conserved in the universe. It really never disappears at all. So that's called conservation of energy or conservation of matter. I extended this by extending the Schrodinger equation, where now we have Photonix images, which are images of non-matter. So by getting non-matter photonic images, we obviously want to say that all the non-matter images are also saved. So when you go back to thinking about Dr. Smith going from DARPA to all those other places and he comes back, all those images are completely conserved. So the identity of the human being is always evolving and changing, but it's always a continuous process. It's never lost. It can be very convoluted. So these images can also change in time as we travel, but they'll never disappear into a void. So they'll always come back. So you could lose an image of somebody, and the Photonix camera can go into the idle mode, and it'll come back 1,000 years later, or a microsecond later, or any time at all. But it'll come back and capture the image. Another thing about the Psychothotonix camera that's different than a regular camera is that the frame rate of the camera is instantaneous. When I saw the electron disappear behind a cloud, simultaneously at the same instant in time, it showed up. So that's kind of a violation of what Einstein called the limitations of the light cone. Because in the regular matter universe, images have to travel at the speed of light, and so they can't show up simultaneously on top of each other. The Psychothotonix camera doesn't work that way. It's much more sophisticated. It has instantaneous shutter speed, so it can see the electron disappears, and instantaneously when it disappears, it creates the anti-electron. So that shows this shutter speed of the camera can be infinite. In quantum mechanics, we talk about the shutter speed basically as being limited by h-bar. It's called the Heisenberg uncertainty principle. You can only resolve the electron to being at some point in space or some point in time, and it's a trade-off. If you see it being 100% at some point in space, then you can't see it in time at all. With the Psychothotonix camera, we can see it instantaneously in space and instantaneously in time. So therefore it violates Heisenberg's uncertainty principle. So we don't need that anymore. With the Psychothotonix camera, we can see everything to be continuous. Photonics matter or photonics non-matter. identities, anything, everything's conserved, and always obeys the laws of duality, which I'll talk about in a little bit. Thank you, nurses.
Absolutely, doctor. I'll go prepare the patient then.
Okay.
If you're sure you're ready.
Yes, the patient is ready. The patient may be able to alter time and bring us back to the universe that we want to be at.